Hi, good evening to one and all. My name is Manoj. Course is B3. The topic is controlling of the traffic lights using electronic. Introduction to traffic light systems. Traffic lights regulate vehicular and pedestrian flow at intersections using time or sensor-based control mechanisms. Second, fixed time systems use pre-programmed cycles, while adaptive systems adjust to timing based on real-time traffic density. Modern systems integrate microcontainers like Arduino for cost-effective, flexible, and scalable deployment. The system operates on the principle of finite state missions, where each state corresponds to a light combination. Efficient traffic controls reduce emissions and tra- travel time, improving mobility matrices. System architecture overview. The core architecture includes an Arduino microcontroller, LED array sensors, and a power supply unit. LEDs represent red, yellow, and green lights to each control a Viva digit output pins with a current limiting resistors. Sensors such that IR or ultrasonic detect vehicles presence ena- enabling adaptive timing logic. A real-time clock module may be added for time-based schedule during peak hours. The system communicates with a perhaps protocols depending on the component requirements. Auditorium microcontrol specifications. Ar- Arduino Uno is commonly used featuring 14 digitals, 1 by 0 pins, 6 analog inputs, and 16 mH clock. A microcontroller executes control logic written in C or C++ using the Arduino IDE and bootloader. Flash memory 32 KB stores the program, whilst PROM 2 KB handles runtime variables and stock operations. Power is supplied via USB or external DC 7 to 12 volts with onboarded voltage regulation. LED driver circuit design. Each traffic light LED 20 to 60 mA is connected to an Arduino pin through a current limiting resistors. For high power LEDs, NPN transistors, MOSFETs act as a switches to handle the higher current loads. The base resistors of these transistors is chosen to ensure saturation. A common cathode configuration allows individual control of each color in digital high or low signals. Sensor integration and signal conditions. Infrared sensors detect vehicles by measuring reflecting light instantly above the threshold. Ultrasonic sensors measure distance using time of flight, where d is equal to 340 into 343 into time by 2, where t is echo duration. Analog signals from IR sensors and digitized using the Arduino 10-bit ADC. Sensor data is processed using resistors or moving averages to prevent false degradation. Finite state mission implementation. The traffic light system is modeled as an FSM with states NS green, NS yellow, NS red, EW green, EW yellow, EW red. Transistors between stages and states and governed by timers. delay 3000 or 30 seconds green phase or sensor inputs. State diagrams and transition tables are designed using Meili or Moore mission models. Each state activates specific LED outputs and detectors other than prevent conflicting signals. The SFM is implemented by using switchcase statements in Arduino code for modularity and variability. Timing algorithms and optimization. Fixed time control uses a cycle time T is equal to cycle is T cycle is equal to T green plus T yellow plus T red plus T all red into all red clearance. Adaptive timings adjustment green duration based on the queue length. T green is equal to T min plus K into N, where N is equal to where N is a vehicle count. The Webster method optimizes cycle length, where L is the total lost time and Y is the critical flow ratio. Phase skipping occurs when no vehicles are detected, reducing idle time and improving the efficiency. Interfacing with real-time clock (RTC). The RTC ensures consistent operation during power outages using a backup battery. Power supply and production circuit. A 12 volts DC adapter powers in a Arduino wire with a win pin with onboard 5 volts and 3.3 volts linear regulators. Reverse polarity protection is implemented using a p-channel MOSFET in series with the input. Transistor voltage suppression, TVS diodes and protect against voltage spikes from a indicative loads. Fuses 1 amps fastball prevents the overcurrent damage to auditory and LED circuits. Software design and code structure. The main loop function iterates through FSM states while setup initializes pins, sensors, and RTC. Time interpreters ensure precise timing with blocking delay calls. Modular functions enhance code maintainability and reusability. State peristate during power loss is achieved using EEPROM write or EEPROM read for critical variables. Communication and remote monitoring. Wi-Fi or GSM modules enable remote access to traffic light status and diagnostics. Data is transmitted using MQTT or HTTP protocols to a central server or good platform thinking speak. JSON payloads include timestamp, current state, sensor readings, and error codes for analysis. Remote commands and processed via REST API and endpoints. Error detection and failsafe mechanisms. Watchdog timer WDT resets the auditory in a main loop scanning, ensuring the system recovery. LED health is monitored used current sensors to detect open this short circuits. Traffic flow modeling and simulation. Simulation results validate timing algorithms and optimize base bits before hardware development. Queue length is estimated using fluid dynamic models where lambda dq by dt is equal to lambda minus u, where lambda is the arrival rate and mu is the service rate. Energy efficiency and solar integration. LED power 1 to 5 volts and orchestral sleep more modes reduce energy consumption during low traffic periods. Battery capacity is 12 volts to 70 amps. LED is sized to support 24 hours operation with 3 days of autonomy. Due to cycling of sensors and LEC minimize power draws. P average is equal to P peak. Safety and standards and compliance. Future enhancements and research directions. AI-based control using reinforcement learning can optimize page timing dynamically. Thank you.